Hi everyone, my name is Darian, and we're going to be going over week 5, problem 5 for CSM CS 61A. In this problem, we're asked to fill in the function has sum, which takes in parameters total, n, and m. And we are also told that this function is going to help assign students to discussion sections of sizes n or m using the parameter total as the total amount of students that we have left to assign. So this function is basically going to tell us if we can create sections and not have any leftover students. So we want this function to return true if we can and false if we cannot. So how should we approach this problem? Since our function has sum, it explores multiple options. This indicates that we should approach this problem using tree recursion, because tree recursion allows us to explore multiple options through multiple recursive calls. In the case of our function has sum, we want to explore the options of either creating a discussion section with n amount of students or creating a discussion section with m amount of students. Now that we know how we want to approach this problem, what should we ask ourselves next? Next, we should ask ourselves what are potential base cases and what are potential recursive cases for this function. Next, let's look at the skeleton code to see what we've been given. We are told that for some if statement, we want to return true. For another if statement, we want to return false. And if both of those if statements are not met, then we want to return something else. Next, what we need to ask ourselves is, when do we want to return true? Well, we want to return true whenever we're successfully able to create these discussion sections and we finish without any leftover students. So how can we check if we have any leftover students in the end? Well, our parameter total keeps track of however many students we have left to assign to a discussion section. So maybe we can somehow use total to check if we have any students left over after creating all our discussion sections. So what can we do? Well, maybe if we check if total is equal to n, or if total is equal to m, we want to return true. But this wouldn't work because if total were equal to n or if total were equal to m, then we would still have n or m amount of students left to assign to a discussion section. So this would not work. So what should we do? Well, let's see. Let's check if total is equal to 0. Do we want to return true? Yes, because if total were equal to 0, then that means we have 0 students left to assign to discussion sections. And under those conditions, we want to return true. The next question we should ask ourselves is, when should we return false? We know we want to return false whenever we create our discussion sections and we end up with leftover students. So how can we check if we have leftover students in the end? So once again, we're going to want to use our parameter total since it tells us the status of the total amount of students that we have left to assign to a discussion section. So how can we use total to check if we do have leftover students after creating these discussion sections? Well, if we were to check if total is less than 0, would we want to return false? So in this case, we would want to return false, because if total were less than 0, this would represent the case where we tried creating a section of either size n or m. However, we did not have enough students to create a discussion section of size n or m. And we actually require more students, which is why our total went into a negative index. And in those conditions, we would want to return false. Okay, so now that we've figured out our base cases, let's think about our recursive calls. So we know we want to approach this using tree recursion. So we want to somehow call back to our function has sum. However, we want to think about a few things. We want to think about the different options that we're able to make and has sum, along with how can we decrement our problem into a smaller problem and somehow combine our recursive calls to return a Boolean, since we know that our function is going to return a Boolean in the end. So first, how can we get our function to represent creating a discussion section of sizes n or m? Well, maybe we can try subtracting total by n, and would this work? Yes, it would actually, because it would represent the case where we are able to create a discussion section of size n. But this recursive call only takes care of half of our options, because we also want to have the option of creating a discussion section of size m. So how do we do that? It's going to be in a similar way, except this time we're going to want to subtract m from our total, since we want to represent the case where we are able to create a section of size m. So we know that in the end we want to return a Boolean. So we need to think of a way to somehow combine our recursive calls to evaluate to a Boolean. Well, we have our Boolean operators and or, but which one should we use? Well, since only one of our recursive calls needs to return true for this function to return true, we know that we should use or. Okay, and to check the functionality of our function, let's run through a dot test. So let's say that we called this function has sum with parameters 5, 3, and 5. We would execute the body of the function, and we would check if total is equal to 0, and we can see that it's not. And total is also not less than 0. So we would reach our recursive calls, and Python interprets code from left to right. So the first recursive call that we would execute is the case where we create a discussion section of size n. So this opens up a new frame and calls this function has sum with parameters 2, 3, and 5. So once again, we go through the body of the function and we check if total is equal to 0, and it's not, and total is also not less than 3. So once again, we check the option of opening a discussion section of size n, and this opens up a new frame with parameters -1, 3, and 5. So we execute the body of the function once more, and we see that total is not equal to 0, but this time our total is less than 0. So what this function is going to return is this function will we'll use red to represent what our function is going to represent, or what our function is going to return. And what our function is going to return is false, because our total is less than 0. So now that this recursive call has been evaluated, this frame closes. And we go back into the frame where we had the function call hasSum with parameters 2, 3, and 5. And now that we have executed the case where we create a section of size n, we can execute the next option of creating a discussion section of size m. So this opens up a new frame and calls our function hasSum with parameters -3, 3, and 5. And so we just execute the body of the function once more, and we find that our total is less than 0. So this is evaluated to, what does everyone think? What does this evaluate to? It evaluates to false. So this recursive call closes, and the return value of our frame where we had the recursive call hasSum with parameters 2, 3, and 5 will also evaluate to false, because false or false is false. And so this evaluates to false, which represents the option of creating a discussion section of size n. So now we can execute the option of creating a discussion section of size m. So we execute the body of the function. Oh, actually, first, we open up a new frame with what might our parameters be? Total minus m is 0. So we have parameters 0, 3, and 5. And we execute the body of the function. And since our total is equal to 0, what is our return value going to be? Our return value for this function call will be true. So in the end, this recursive call with parameters 2, 3, and 5 evaluates to false. And this recursive call with parameters 0, 3, and 5 evaluates to true. And in the end, we will return true, because false or true is evaluated to true, which is what we expected from the doc test. That is it for this problem. If you have any more questions about this problem, feel free to post on Ed.